Hi everyone, Chris Tisdell here again. Thanks for tuning in. In this presentation, I'm going to continue my series of videos on a beginner's guide to calculus. And in particular, we're going to do an example where we look at the range and domain of a simple polynomial, a simple quadratic function. So here's the example that we're going to look at. Compute the domain and the range of the function defined by this quadratic x squared plus 2. Now, some of you may be going, well, that's easy, Chris, I can do that. Yes, it's pretty low on the difficulty scale, but it's a little bit tricky. And generally, ideas like domain and range, people feel they understand them, but they can't quite put their finger on them. So let's remind ourselves what domain and range is. Now, for a function, basically the domain gives us a set of allowable inputs. What are the inputs, the x values that we can put into this function so that we don't break the function, like dividing by 0 or something like that, okay? And the range of a function is the set of achieved outputs. So given an okay input, what kind of outputs can we expect from our function? And in previous videos, I talked about some top tips. So for domain, you can't divide by 0. You can't take the square root of a negative number. And for range, the square roots can't be negative. And if you divide a constant by a function, you can't get a 0 output. Okay, so let's get back to this example now. Okay, so firstly, let's look at domain. All right, so first of our top tips, can't divide by 0. Is there any division going on here? No. Can't take the square root of a negative number. Any square roots? No. So essentially, I can put any real number into this function, any real value of x, and nothing will break. Okay, I square it, I add 2, and I get an output. So with this one, the domain is really easy. So I use DOMF to denote the domain. And in this setting, I'm going to use this interval notation. Okay. So if I was to draw this on the number line, it would just be the whole number line. Okay. Okay, think of this as the x number line, if you like. Okay. Now, what about the range? The range is a little bit trickier. People go look at this and go, well, the domain, the range is just the same as the domain. Not true. Now, for the range, we see we're asking ourselves, what kind of output do we get? Okay. So firstly, if you look here, we've got a squared and we've got a plus 2. Now, x squared always has to be greater than or equal to 0. Okay, for any x value in this interval here, one thing that we can say about the square of something is that it's always greater than or equal to 0. So now what we can do is form an inequality. Okay. X squared is greater than or equal to 0 for all x in, sometimes we can write this as this curly r, so I'll write that, the set of real numbers. Okay, so we can now form an inequality. X squared is always greater than or equal to 0 plus 2. So this tells us then that the output is always greater than or equal to 2. Okay, and if x equals 0, then the output is 2. All right, so now we can talk about the range of f as this interval. Okay, so I've used the square bracket there because the output could be equal to 2. If I'd use the curved bracket if it was strictly greater than 2. So we now have our two sets, our domain and our range. And if you draw a picture of your quadratic, it's pretty obvious that these two things hold. So let me just finish with a picture. Now, the graph of this, x squared plus 2, is just the graph of x squared moved 2 units up the y-axis. Okay, and it cuts the y-axis when x equals 0, so it'll cut at 2. Now you can see from this picture, for every x point on the x-axis, there was a corresponding y point, so it's the domain of this function is any real number in there, or all real numbers, and the graph doesn't go below 2. So that's what we mean by graphically by the range. Okay. Okay. Thanks for watching, everyone. A simple example. Hope you can see its simplicity as well. And the way you get good at these problems is just do lots and lots of problems. Hope you can join me for more presentations again. See you later, everyone. Bye.